Hello there, welcome to Learning with George. This is my second tutorial. It's going to be slightly more academic than the first one. This one's going to be on the mathematical function of pi and some of its basic uses. It's typically a Key Stage 3 topic, so sort of ages 11 to 14, years 7 to 9. As always, if you've got any questions, drop me a message or comment below and I'll get back to you as soon as I can. Okay, so as I say, what we're going to talk about today is pi, symbolized by this character here, sort of like a lowercase n. We're going to talk about what it is, what it's used for, and give you a couple of useful equations that will probably come up in your exams. Okay, so before we start, it's good to define a couple of things. So obviously we all know what a circle is, but the key to remember is that a circle is a round 2D shape that's symmetrical in all directions. What that means is that the distance across the centre is always going to be equal wherever you draw that line. It's important to know that a circle is symmetrical because if we're talking about an oval where these distances might be different, then our equations aren't going to work. So the equations that we're going to talk about later are only going to work with a true circle which is symmetrical in all directions. Okay, so the next thing to be defined is the diameter of a circle, which is the distance from one edge to the other through the centre of a circle. So all of those lines that I just drew on in the previous slide were examples of a diameter. So it's just the distance from one edge to the other going through the centre, so the maximum distance across a circle, if you like. And similarly, the radius is actually just half that distance. So it's the distance from the center point of a circle to its outer edge. So you can see there that D is for the diameter across the whole circle, and R is for the radius, which is just half of that. Okay, so next, the circumference is defined as the distance around a circle. So it's that distance represented by C all the way around the edge of a circle. That's the circumference. Okay, so going back to pi then. So what is it? First of all, is the first thing to know is that it's a constant. So it's always going to be the same value, which is equal to approximately 3.1415926535589, and that will go on forever. And all of those digits will be random. You can try and remember as many as you like if you sort of are that way inclined, but usually it's just going to be two decimal places that you're going to need to know that to, so just 3.14 is what it's usually used as in simple equations. You should also have the function on your calculator which will have it more accurately. So you can look out for that if you've got a scientific calculator. Now, the fact that it does go on infinitely and doesn't settle into any patterns is part and parcel of what makes it an irrational number. So I'm not going to go into too much detail on rational and irrational numbers in this presentation, but essentially a rational number is a number that can be defined as fraction a over b, where a and b are both integers or whole numbers. So just a few examples of rational numbers are whole numbers. So anything that's a whole number can be defined like that, with just divided by 1. Decimals with a finite number of decimal places, and those examples on the left can be defined as those on the right. And finally, decimals with an infinite number of recurring decimal places. So a common example would be a third, for example, which would be 0.3 recurring. And that's going to be defined by 1 divided by 3. Now, as I say, I don't want to go into too much detail on that now, but if you are interested in learning a bit more about the proofs behind how to convert those decimals into fractions in the form that we've been talking about, then I'll leave that in the description of the video so you can look at that in your own time. But basically, rational numbers can be defined as a divided by b, where a and b are both integers, But in the case of pi, pi has an infinite number of decimal places, and its decimals never settle into a repetitive pattern, which means that it can't be defined as fraction a divided by b, where a and b are both integers, and therefore it's an irrational number. So just before we go into how it can be defined, I just wanted to mention the history of it for anybody that's interested. Its earliest written approximations were between 1600 and 1900 BC. And this was in Babylon, Mesopotamia, which is now known as Iraq. They estimated pi to be 25 over 8, which is approximately 3.125. And in Egypt, they used a formula around about the same time to estimate pi to be 3.16. So, as we've mentioned previously, we now know that pi is closer to 3.14, and we only know that because technology has advanced a little bit. But they did know the theory behind pi as far back as 1900 BC, so it's been around for a long time. We just know it slightly more accurately now. So anyway, what we're all here for is to find out what pi is and what it's used for. So it's defined as the ratio of a circle's circumference to its diameter. Now what that means in its very simplest terms is that essentially you can times the diameter of a circle by a constant, and that will always get you the circumference of that same circle, and that constant will always be pi. So circumference equals diameter times pi, or if you wanted the symbol equation, C equals pi times D. So what that means in a sort of practical sense is that if you times the diameter by any sort of constant, the circumference will go up by the same amount. So here on the left we've got the diameter as D and the circumference as C. On the right you can see that when the diameter is doubled, the circumference would also be doubled. So 2 times the circumference is 2 times pi times D, and that's the same for any constant that you're gonna times the equation C equals pi times D by. So they're proportional, and as I say, the circumference is always the diameter times by that constant pi. So this is quite a good diagram. Quite a good animation of how that's worked out. So in the blue columns, you've got the diameter of a circle back to back, and then the red line is the circumference of the circle. And as you can see, when you put those beside each other and then you roll the wheel along, the circumference goes along the bottom, and that will be approximately 3.14 times the diameter, which is that pi figure. So as I say, that's sort of a visual way of realizing how that diameter is related to the circumference. Okay, so let's move on to practical uses then. Obviously with that equation, if we know that D is equal to 10, we can work out that C is equal to pi times D, which is pi times 10. So we know that the circumference is approximately 31.415. Similarly, if we had the circumference of 90 and we were looking to find out what the diameter was, you can rearrange that formula C equals pi D by dividing both sides by pi. C divided by pi equals D, and then substituting in 90 into that formula, the circumference of 90 will get you the diameter equal to 90 divided by pi, which will equal approximately 28.647. So if we were just to do an example together, Tom has been asked to plant seeds around the edge of his mum's circular flower patch. According to the instructions, the seeds must be planted at least 0.5 metres apart. The flower patch has a diameter of 4 metres. What's the maximum number of whole seeds that Tom can plant? So if you wanted to pause the video now so you can try and work that out, we can go over it momentarily. Obviously the first thing that we need to do is work out what the circumference is. So you use your formula C equals pi times D. C equals pi times the diameter of 4, which will get you 12.57 metres. And then the question isn't quite over because we're actually looking for the number of seeds which must be planted at least 0.5 meters apart. So in order to do that, you need to divide the circumference by the distance apart, which is 0.5, and then that equals, that will get you to 25.14, but obviously you can't have 0.14 of a seed, so it means that the maximum number of seeds will be 25. So that's just an example of the sort of question that might come up using that formula. So then just before we finish then, so the other formula that we also know is how to find the area of a circle using pi. So the area is the squared amount inside that circle, and the formula for that is going to be area is equal to pi times the radius squared, or if you like, a equals pi r squared. So in the exact same way, you can use that if you've got the radius of 10 meters, you can then use your formula a equals pi r squared, substitute in the value of 10, work all of that out, and you'll get 314.16 meters squared for the area. And if you just started with the area of 150 meters squared, what we just do is rearrange that a equals pi r squared formula. So rearranging it, you basically just want to get r on its own on one side of the equation. So to do that, you'd first divide both sides by pi. So a divided by pi equals r squared, and then you find the square root of both sides. So the square root of a divided by pi equals r. You substitute in your value of a, which is 150, and then put that into the calculator, and you'll get approximately 6.91 meters as the value of the radius. So again, that's fairly similar to how we use it in the other terms. It's just substituting in any value that you've got of the radius or the area in order to find out what the other one is. So just to conclude, a handy way to remember it if you think that you might forget it. This one was influenced by Lewis Carroll's Alice in Wonderland. A little poem to help you remember is Tweedledum and Tweedledee, around the tree is pi times d. And if it's the area to be declared, use pi r squared. So there you are. Hopefully that was helpful and proves to you that my knowledge extends to further than just coffee. As I mentioned in my last tutorial, I am offering one-to-one sessions for anybody that wants to learn further. Just drop me a message and I'll give you some more information. Thanks very much.